Hi guys, welcome back to my channel. So how do you solve this integral? This is an MIT Integration B question of 2024 season. So please subscribe to my channel for more of these videos. So let's solve this integral. So let's start off by calling this integrand y. We can let 1 plus 1 plus all over x plus, this is an infinite sum over x plus 1 plus that all over x plus that. Yeah, we can let this one to be equal to y. That is the integrand. So in that case, we can express y in terms of y and x here. So if we want to express y in terms of y and x, so we have y to be equal to the whole of this. So this is 1 plus, this is the same as y. This one here is the same as y because that is an infinite sum. So that is y all over x plus, this is the same thing here in the denominator. This is the same as y. That is an infinite sum. So this is y. So y can be expressed in terms of y and x like this. So we will have to now find an expression for dx. So you have to isolate x here. So isolating x, that we can multiply by x by y times 1 plus y like this. Okay, so this is xy plus y squared equal to 1 plus y. So isolating x is going to be, we have x to be equal to 1 plus y minus y squared, all divided by y. And that can be expressed as 1 over y plus 1 minus y, like this. Okay, so we can now find an expression for dx, that is differentiating x with respect to y, dx dy, which is going to be, differentiating this is going to be negative 1 over y squared. This is a constant that is 0 minus 1. So that is equal to negative parenthesis 1 plus 1 over y squared. So it means dx is going to be equal to this dy. So we have an expression for dx which we can plug into our integrand. Now what about the limits? X is equal to 1 for the lower limit and 3 for the upper limit. So we can find an expression for y and x here, right? We can find the values for y for the lower limit and the upper limit. We can do that in a different color. Okay, so x is equals to 1 over y plus 1 minus y. Now when y is equals to, when x is equals to 1, that is a lower limit, we have 1 to be equal to 1 over y plus 1 minus y. This one and this one will cancel, and in the end you have y to be equal to 1 over y like this, or y squared minus 1 is equal to 0. So when this happens, you either have y to be equal to plus or minus 1. That is y is equal to 1 or y is equal to negative 1. And since x values are positive values here, then the y values must be positive. So we are taking the positive value of y here. So y here is going to be 1. So when x is equals to 1, y is going to be 1. Now the upper limit. When x is equals to 3, what is going to happen to the value of y? What will be the value of y? So we have 3 to be equal to 1 over y plus 1 minus y. 3 minus 1 is 2. So that is 2 to be equal to 1 over y minus y, like this. So this one, we can really simplify this one into 2y to be equal to 1 minus y squared. Or you can have y squared plus 2y minus 1 is equals to 0. And you use the quadratic formula to find the values for y here. So the quadratic formula says that y is equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. And here our a is going to be equal to, a is going to be the coefficient of y squared, which is 1, b is going to be the coefficient of y, which is 2, and c is the constant, which is negative 1. So we can plug those into our quadratic formula. So y is going to be equal to negative b. b is 2 plus or minus the square root of b squared, which is 2 squared, minus 4ac. A is 1 and c is negative 1. All over 2a. A is 1. So y is going to be negative 2 plus or minus the square root of 4 plus 4, because minus minus all over 2. So that implies that we have negative 2 plus or minus the square root of 8 over 2. So y is going to be negative 2 plus or minus the square root of 8 is 2 root 2 over 2. And that cancels to be negative 1 plus or minus root 2. But we are taking the positive value of y here. So the positive value of y here is going to be when this one is plus. So y is going to be negative 1 plus the square root of 2. So there you have it. When x is equals to 3, that is the upper limit. The limit for y is going to be negative 1 plus the square root of 2, like this. And when x was equal to 1, y was also equal to 1. So there we have our limits. So now we are ready to take our integral from the x world into the y world. So the integral now becomes, sorry about that. The integral now becomes, the integral from the lower limit here is going to be 1 for y, and the upper limit is going to be negative 1 plus the square root of 2 of y times dx. Remember, this one is y times dx, and dx we found an expression for dx, which is this one, negative 1 plus 1 over y squared times negative 1 plus 1 over y squared dy. All this is multiplied by y, and then negative can go all the way in front. 1 negative 1 plus the square root of 2 times y, 1 plus 1 over y squared dy, like that. Okay, so we can switch the limits, and that will nullify the negative 1 plus the square root of 2 to 1 of, we can multiply 1 plus 1 over y dy. This is not trivial. So our integral now becomes, integrating this, that's going to be 1 over 2 y squared plus the ln of y, and you are integrating from negative 1 plus the square root of 2 to 1. Okay, cool. This is 1/2. You now plug in your limits. The upper limit first, this is 1 squared plus ln of 1. Upper limit minus lower limit, 1/2 negative 1 plus the square root of 2 squared plus the ln of negative 1 plus the square root of 2, like this. This is 1/2. Ln of 1 is 0 minus, this is 1/2 times, you can FOIL this, and that will be 1 minus 2 square root of 2 plus 2 plus the ln of root of 2 minus 1. And this is 1/2 minus, we can now multiply in with your half. This is okay, we have half minus root of 2 plus 1 plus ln of square root of 2 minus 1, like this. So we have 1/2 minus 1/2 plus square root of 2 minus 1 minus the ln of the square root of 2 minus 1. And this cancels out, and they are left with the square root of 2 minus 1 minus the ln of the square root of 2 minus 1. This is not the answer MIT gave. So if you want to get the answer MIT gave, that we are going to do some simple manipulations here. And this is plus, this negative here, I can bring it all the way to the power using the laws of logarithm. That is ln of the square root of 2 minus 1 raised upon negative 1, like this. And you have root of 2 minus 1 plus ln of 1 over root of 2 minus 1. Then we will rationalize, that is root of 2 plus 1 over root of 2 plus 1. So this is square root of 2 minus 1 plus ln of root of 2 plus 1 all over, this is difference of two squares, so the square of root 2 is 2 and the square of 1 is 1, like this. And this one really simplifies to root 2 minus 1 plus the natural logarithm of square root of 2 plus 1. So this is the answer that MIT gave for this integral. So that is the value of our beautiful integral up there. So if you find this helpful, make sure you give me a thumbs up, subscribe to my channel for more engaging content like this. I thank you so much for watching this video, and I will definitely catch you up in the next one. Bye bye.